from different threads, so it needs to be guarded. So this is just an example of how much nicer Rust is. And it's not just the language; it's also the ecosystem. So on the Rust side, to do HTTP requests, I can just use so over here in binary cache store, I can just use hyper. So I can say client.get on a URL. And that's all I need to do. Whereas on the C++ side, so we use libcurl, but libcurl is not a super friendly API, especially not from C++. So we have this giant monstrosity to handle downloads for us. So it's almost 1,000 lines of code just to do HTTP requests. So that's all code that you can just get rid of if you're in Rust. So that's a much nicer world. So it would have been great if Nix was written in Rust from the start, but it isn't. So all this nice code is basically useless. So we can't use it in the C++ code base because there is no very clear story as to how you could extend the C++ code base in Rust. The Rust C++ interrupt story is not very great. Basically, the interrupt story is Rust and C, so you can call C functions from Rust or vice versa. But doing any sort of non-trivial interaction with a C++ code base, as far as I know, there are not really a lot of good solutions for that. So, for example, in this particular case, what I would really like is to write things like store implementations in Rust. So something like the binary cache store would be pretty trivial to rewrite in Rust, as this example shows. But the problem is, of course, that it needs to subclass the C++ store class. So that's this thing over here. So in the C++ code base, there is this store class, and we would have to somehow subclass that from Rust. And that's not possible. So so I don't know how to do that. So that's for now. All this code over here is it's toy code. It's nice, but it doesn't do anything. So
it seems to explain that if Nix were in Rust, it would make you a lot happier, right?
Yes. Yeah.
You seem to enjoy it a lot more, and you did say that you wish that if Rust existed, you could have written it in the first place, but that wasn't available.
That's right.
And you want to find a way to incorporate somehow, but you said the interoperability sort of story is not great. So
yeah, as far as
this is sort of a toy for you.
Yeah. Well, okay. So what I was going to say. So we are actually now using a little bit of Rust, but it's mostly things that don't require a lot of close interaction between Rust and C++. So, for example, the first thing implemented in Rust, in Nix, is support for tar files. So it used to be that. At various places in Nix, we need the ability to unpack tar files, and we used to do that by calling tar. But that requires having GNU tar or something else in the Nix closure, so that's a bit inefficient. So now it's using the Rust tar crate. So there is this little function unpack tar file, which takes a path, which is the path to the path to the destination directory, and it takes this thing called a source, which is basically the Rust read class. Only it's actually the C++ source class that we have in Nix. So that actually allows calling back into the C++ code. So yeah, so this just uses the tar crate to enumerate the contents of a tar file, to write it to disk, so create directories, write files, create symlinks. Yeah, and so we can call this from C++. So there's a little bit of complexity going on here, but not much really. So we use extern C bindings. So there's no extern C++ if you want to. You can't pass. You can't call C++ functions from Rust. You can only call C functions, and yeah, and vice versa. If you want to call a Rust function from C++, you have to write essentially a wrapper function on the Rust side that has C linkage. So that's this unpack tar file function. And some complexity around error handling. So obviously Rust and C++ have very different error handling strategies.
Yes.
Uses exceptions, and Rust uses enums. When the Rust code calls C++ code, which happens implicitly when the tar crate reads from this source object, C++ exceptions can get wrapped inside a error type and then get reflown if they go back into the C++ world. So yeah, that's yeah, not very pretty, but kind of unavoidable.
So on this topic of interop, I know there's been some heartburn around some of the choices about the data types being used in Rust and used in C++, and some concerns around how the ABI for C++ isn't stable and the ABI for Rust isn't stable. So how do you take two unstable ABIs and have them happily talk to each other?
So I don't. I just assume that it keeps working, and if it breaks in the future, then we'll have to fix the code. That's basically what happens right now. So, for example, currently, so it's an example of that. Yeah, so for example, for the result type, so that this C++ wrapper type, well, so it's not a wrapper type, it's actually a data type where we assume that it has the same in-memory representation as the Rust result type. So that there is an enum that has two values, and please ignore the third value, it's therefore boring reasons, and that it's followed by the contents of that type. Or the error, which is always an exception point in this case. But so in theory, yeah, the in-memory representation of the result type could change. So if they change the Rust compiler or the definition of the result type, then this could change, but it's not particularly likely that will change.
Sure.
They do.
I believe we have some of the question. It's Puck.
Mm-hmm.
Hi, yeah. I have been the one that has been also noting some of these concerns because there's more issues than just the fact that the ABI, for example, one of the examples which I am somewhat surprised you haven't hit yet is that the Rust does niche filling, where in the case that an enum, for example, if you have a box of some sort, it can't ever be null. So if you have so it can do some optimizations by using the null value for something else.
Yeah.
I've mentioned this. I've shown this code to a Rust developer and stuff, and I'm kind of scared not just about this just breaking, because it may break in. It may even, but also because a lot of this is incredibly undefined behavior, obviously.
I don't think it's so much undefined behavior as it's unspecified. I mean, the layout of a data type is deterministic. I mean, it must have a specific layout. It's just that that layout is unstandardized.
The layout of a Rust. Sorry, continue.
So it's so undefined behavior can occur if the compiler starts making. So, for example, in C++, if you have something like you call through or you try to do something with an uninitialized variable, then anything could happen, and compiler could be making arbitrary assumptions or optimizations. So anything could happen there. But here, the layout of a data type, it must have a layout. So that layout might change in some future version of the compiler. It's not suddenly going to change, yeah. So I don't think there is a undefined behavior there, or there's no possibility that the Rust compiler or the C++ compiler would perform some optimizations because of this.
The layout of a struct in C++ is, as far as I understand, completely defined. But in Rust, anything that's wrapper Rust, like the Rust representation, is not only not specified structure, but it is also completely unspecified, even if two compilations of the same binary, of the same source, will end up with the same struct layouts. That is all allowed to change. And I've actually been talking, and we have been thinking about actually changing a very slight, or like making a very slight change in the Rust compiler and then just testing it out. Namely, what happens if you rotate the error and the OK in the enums. The issue is to make this work properly. There's some other bits, but this would, for example, break horribly. This code would break horribly in that situation.
Yeah, so of course. So if that changes, then this will break, and then we need to fix this. But yeah, so I'm relatively unworried about that. I mean, so it makes other assumptions here, like the layout of a slice, that's a pointer followed by a size. Yeah, that's also something that they could flip those around. But yeah, I'm not worried about that. If they do that, then we need to fix it on the C++ side as well. But I mean, on the whole, I would say it's a systems language. Shouldn't be too afraid of bit fiddling.
That's what wrapper C is for. That you get a defined structure and that you don't pass things through an F5 boundary that aren't allowed to go there.
Yeah, so
like fat pointers.
So then you need to define all these kind of pointless wrapper types just because of the theoretical concern that something might change in the future.
I don't think this is just theoretical. Yeah.
So, I mean, of course it could happen, and then if it happens, it's a 1 minute change.
Eelco, I believe Peter Simmons has a question for you as well.
Go ahead.
We can come back to Puck in a second. It's okay. You're part of the discussion, Puck. Okay, Peter, are you here?
Yeah, hi. Hi, Eelco. Thanks a lot for the presentation. I hope you guys can hear me all right, because the audio that I'm receiving sounds a little garbled. So I hope that it's not me. And
it's a bit scratchy, but it's okay.
Yeah, okay. Eelco, I was wondering, suppose that Nix would be written in Rust. This means that basically Rust would become a system dependency of the lowest level of the whole ecosystem, right? You would need a Rust compiler to compile Nix. And my understanding, I have very little practical experience with Rust, so I don't know for sure, but what I've seen is that compiling Rust is actually not that simple, because the compiler is moving very quickly and involves the language standard, so you can't just use any version of the compiler to compile any other source code. You need very specific version ranges to get certain features, and the build runs for several hours on a fast machine, and this is all sounds to me like this is a major investment, right? That we say, yeah, you have to provide the Rust compiler before you can build Nix. Is that, do you share that concern, or do you have a workaround for that, or am I just completely off with that notion?
Yeah, so that's an issue, but I mean, fortunately, we have Nix for that. So if you just run Nix shell, then you get the build environment for building Nix. So which includes the Rust compiler from the binary cache. So in practice, it's yeah, it makes the sort of the closure for building Nix bigger, obviously, or quite a bit bigger, because Rust is pretty big. So yeah, I mean, that is a downside, but I think actually the bigger problem is that if we start rewriting things in Rust, it reduces the number of people who can contribute to the code base to the intersection of C++ and Rust developers, which is of course a smaller set. So that's probably a much bigger problem than having a dependency on the Rust compiler.
And Samuel and IRC also mentioned that he hasn't been able to get Rust cross-compiled for now. So he has a similar concern as Petty.
Okay, yeah, so I don't know about that, but I think in principle, the Rust cross-compilation situation, as far as I know, is much better than with C++ compilers in general. But I might be wrong about that. But as far as I know, it's pretty easy to cross-compile Rust code, or at least if you want to do things like compile to WebAssembly, that's very easy. But yeah, it might be some problems there. It might be that it's more of a problem in how we hook up Rust and Cargo into our make files. But yeah, I haven't tried it.
So here's a question from the Zoom chat from Toby. He's curious about the vision and of the future of Nix with regards to C++ and Rust. If the interop between Rust and C++ will improve, or if eventually you do expect that the majority or all of Nix will be in Rust, what's the future of Nix plus Rust out beyond being like a toy implementation?
Yeah, so I don't really know. I mean, so in the current state, so there's just a little bit of Rust code being used, so that if it stays like that, then that's actually not really worth it to keep it around, because it just adds more complexity to the build. So yeah, hopefully we can figure out some way to do things like write store implementations in Rust, or do things like write the Nix CLI in Rust. Because I mean, that's also the sort of thing that would be much nicer in Rust, because you can use all these nice crates for like struct up for command line processing. So yeah, that remains to be seen. I mean, so this is mostly, yeah, why I started experimenting with this, to see how easily we can start swapping out parts of the C++ code base by Rust components. So yeah, it would be nice to try to do something like replace the, I don't know, the S3 binary cache with a Rust version, and see what would be involved with that in that.
That makes sense. I think there are some other questions around using Nix packages to cross-compile, using Nix packages cross-compilation support. But I suppose that's something to explore. Flocally is asking, what if we converted components of Nix into Rust first on one side of the daemon protocol, and then then tackling Rust on the other side of the daemon protocol, so that we can use that protocol to avoid the FFI concerns?
Yeah, but so that doesn't really help, because on both sides of the connection, you need a huge amount of C++ code. Actually, you need basically the same amount of code. The only difference between the daemon and the client side is whether you use the remote store or the local store class. So yeah, everything else is the same. So there's not a, I mean, so rewriting the daemon in Rust would actually be very nice if for say security. But yeah, then you would have to rewrite local store, which is yeah a huge amount of code. So I mean something like, well, so local store.cc is 1500 lines, build.cc is 5,000 lines, and there's a lot more source files, and so that's all the stuff you would have to rewrite just to get the daemon to work. And you would still need it on the C++ side, on the client side as well, because you don't have to run Nix in client server mode, right? So you can have if you're running as an unprivileged client, you don't have to go through the daemon. So yeah, so unfortunately, yeah, that's not a viable approach, I think.
What about using some sort of serialization protocol internally? So the REST components and the C++ components don't FFI exactly, but for example, maybe use a self socket, like between it and its own self.
But that sounds like it would actually be more code than FFI. So the problem with the C++ FFI is that you need to do a lot of marshalling to get, say, C++ data types into the C FFI format, and vice versa. And if you went, but so now you would have to write quite a lot of code. But if you serialize it, you also have to write a lot of code. So it would not necessarily be easier. And in the current implementation, with all this FFI hackery, it actually avoids a lot of the FFI overheads or that marshalling stuff. So, for example, you can actually return a Rust string directly to C++ and have move semantics there. And you can use it directly from C++. So you can convert that thing to a string view and access the data directly. So you don't actually have to do any potentially annoying marshalling or going through C data types or things like that. You can even do things like returning vectors. So a lot of the annoyances in the FFI can be avoided, I think. It's mostly that, so if you have a class like the store class, so if you want to implement, say, part of a store implementation in Rust, I mean, the whole, Rust is not a real object-oriented language. We have a concept of inheritance. And obviously it has absolutely, there's no way to make, say, Rust and C++ classes interact in any sensible way. So yeah, that's really the annoying thing. Not so much passing basic data types around.
So going back to the concerns that Puck raised, I understand. I understand both sides of the concerns, both in that it is undefined, and perhaps the Rust compiler will optimize a given compilation differently from another. I'm no expert in Rust, so I would defer to Puck on that. But I wonder if there's a way that we could test on the C++ side to see if, to sort of like pre-flight check to see if the compilation produced data layouts that we're expecting. I don't know, I'm out of my league, but maybe you have some ideas.
And
That would certainly be possible. Although I would say if the layout differs, then it will segfold anyway, so you find out very quickly.
I believe Puck had something to mention, Eelco.
yeah,
Okay, go ahead.
it's not really like you could write a bunch of functions that allow you to request the size of a specific struct and stuff from Rust into C++, or you could do like client checks at compile time. But honestly, it isn't that much code to make to just basically write C bindings for the existing. For example, the store class, you could write a function. You could write an implementation of that class that just differs everything into a Rust extern C set of functions, and then on the other side have the exact opposite, where you have where you also have a dynamic trait object that you then use to implement, that you then use to have a generic store on the Rust side.
Yeah.
Also do the opposite to get a dynamic, to get a specific implementation of a C++ store into Rust.
Yeah.
That's not too hard to do, and I think it's pretty standard practice even.
Yeah, but it's just, I mean, going through the CFFI makes all of that very tedious. So for example, the fact that, say, the Rust compiler doesn't know about what's it called, the C++ name mangling. So even if you have a C++ function that takes basic data types as arguments, you can't call it from Rust. You have to put a C wrapper around it. So that's the sort of thing that's really annoying.
Yeah, the idea would be that you have an extern C function that takes a pointer to a store from the C++ end, and then calls whatever function you're calling on that.
Yeah. But then you have problems like, well, that pointer to the store. So it actually should be a C++ SCD shared pointer because it's reference counted. And then you get the problem that how do you make the reference counting work properly in Rust? So you need to do something more there.
Yeah, at that point you'll have to take a pointer to a shared pointer and I mean, isn't that what you've basically been doing already? Well, with the C box, which is also...
Yeah, the C box is gone. I got rid
Well,
of it.
yes, I know, but
yeah.
Also...
But yeah, so I mean, that's very... not a good approach, because then you get these problems like... I mean, things could leak if you're not very careful. So if the say the Rust wrapper around that unique pointer gets dropped, then you need to make sure that the C++ ref count gets decremented. And I mean, it's all doable, but it's tricky.
yeah, that's kind of what you get when you start FFIing between two incompatible languages.
Yeah.
I'm seeing several questions people are concerned around the idea that it'll just segfault, especially when using larger amounts of memory, like when evaluating, and wondering if there's ways that we could handle this failure without relying on segfaults.
So what's the scenario here? So under what sort? I mean, so if say make install check succeeds, then I mean, okay, suppose that we're using so imagine, so we have these string slices here, and imagine that the Rust compiler decides to flip these around. So we're using these slices everywhere. So they're definitely covered by make install check. So if these flip around, then the program will crash right away. It's not going to crash randomly for certain inputs. It's going to crash pretty deterministically. The test suite will cover that. I mean, we can definitely add an explicit test for it, but my point was kind of, I mean, that test doesn't really add a lot over the implicit test. I mean, this is already covered.
What other data types are we using that that would reliably fail?
So right now we're actually only using one Rust data type. So we're using this store path type. So on the Rust side, there is so it used to be that in the C++ API we passed paths around us as unchecked strings, and now it's a more so hey, you could pass a completely invalid store path to a store function. So for example, a couple of weeks ago we had a bug report that it doesn't actually check anywhere whether the name is non-empty. So nowadays so now it uses a store path value. So all these functions in store API, like say is valid path, takes a store path as an argument, and the constructor of store path checks that the store path is valid. So the hash part of the store path is a base 32 hash. The name part is non-empty and only contains valid characters. So if you can construct a store path object, then you know that it's a syntactically correct store path. So after that, you don't have to check anything anymore. So it's just a more type-safe interface. So the store path class is implemented in Rust. So yeah, so that's the main use of a data type in Rust. But actually, the C++ side makes very few assumptions about the internal structure of this type. So on the C++ side, it looks like this. So for example, there are functions like store path name, which gets the name, but it calls the FFI function to extract the name. So it doesn't make any assumptions about the internal layout. The only nasty thing here is that currently it needs to know what the size of a store path object is. So that's currently hard-coded in on the C++ side, and that's obviously very nasty. So the way that should be done is that you should probably have some build.rs that generates a header file containing the sizes of these types. But other than that, it doesn't make any assumptions about the internal structure.
So actually, so on a different topic, we have about 5 minutes left. So we're certainly not going to cover everybody's feedback here. If people wanted to get involved and discuss this further, is there an ideal place to have this conversation that would work for you?
GitHub or IRC. Yeah, all this discourse, all the standard channels.
Would you prefer, maybe we could start a GitHub issue to discuss this further?
Sure.
Okay, cool. Does anybody have any final or further topics or things
Graham,
they'd like to say?
I think that actually a discourse post would be better for that kind of discussion. I'm not sure if it's
You
more
got it.
accessible, but you can log into Discourse via GitHub.
You got it. That sounds fine to me as well. Yeah. All right. That sounds good. Okay. So unless there are further questions, I have one more, which is looking at the store path implementation. I wonder what would it look like if this went through the repr C and the proper C-based FFI bindings.
It would look mostly the same. It would just be a bit more verbose, I think. Oh no, well, that's probably not entirely true. Yeah, okay, so instead of passing a string slice, you would pass a pointer to a C string and a size field, things like that. So it makes things a bit more verbose, or a lot more verbose. And yeah, okay, and then probably, so I mean, the adventurous part really here is having move semantics between Rust and C++. So these values like store paths, we're not returning pointers to these things, but we're returning the actual values, which works fine because Rust values are all movable. It's just that the only complication is that in C++, whether a value has been moved out of is a dynamic property. So if you move a Rust value around, you have to know when to run its destructor or its drop function, and that makes it a bit tricky. But probably returning structs like store path, yeah, I'm not sure whether that's covered by the API. I mean, it doesn't give any error messages about it, so I suppose it's fine. But I think it's fine as long as you don't return it, but pass a pointer to where it should be stored.
Okay. All right. Well, that brings us to the end of our time here, actually. I see a little bit more, another comment from Toby, but we'll have to take that to the discourse thread. World of Peace, is that something you could open?
Yes, I was already planning in my head.
Wonderful. All right. So we'll get that open right after we end this call. For what it's worth, our next edition of Office Hours is on December 27th. It'll be probably pretty casual with like a pull request review, nothing too committed. And it may also not even be recorded because I'll probably be out of town, but I will be present. Thank you everybody for coming. Thank you, Eelco, for coming and talking about your work with Rust.
Yeah, thanks.
I somewhat anticipate a vigorous discussion on Discourse about it.
I do as well.
All right. Thank you all,
Okay.
everybody. And
Bye.
we'll see you all in a couple weeks.
Yeah,
Okay.
thank you. See you later.
Bye.